Today we're going to be learning Erlang. It's been a tough morning, so um, I'm going to try to get started. I thought if I just don't turn this shit on, it won't ever get started. Look, I got my local first socks. I'm going to put these on because it's getting cold. Oh, it has a nice logo. Oh, I think I woke up with allergies or I'm sick, and it's just a mess today. It's Monday on top of things. I tend to like schedule my Monday to fill it up with stuff that I expect to get started for my week. But it's really the worst day to do things for because I'm just not started up. I don't remember what I was doing. It's really a mess. But anyway, let's forget all that and figure out how to do some Erlang today. I will figure out where my Erlang page is. Okay, here we go. All right, let's get started. Here we go. Let's get psyched. I think this thing's too big though. No? Yeah, it's too big. Gotta make this one smaller. Da, da, da. That's good enough. I'm sorry. I'm sorry. Like, I know it's better to be upbeat and everything, but geez, it's just hard. Okay, what were we doing? Let's look at the home. We were here. We did all of these things. We're learning Erlang, which is a language created in 1986 by Ericsson, a phone company in Sweden, and it's the language that gave rise to the virtual machine Beam, which is like the JVM for Java. Beam is for Erlang, and now on top of Beam we have Elixir, we have Gleam, we have a couple of other languages. Um, and it's really great for parallel computing. So that's its kind of specialty. And I'm enjoying it. I use Elixir already, so this just helps to expand the libraries I use and also maybe mix in Erlang when it makes sense. Okay, I think we did recursion, higher order functions. You can look at my playlist for Erlang on YouTube, and you will see what that's all about. Do I have the right title for this stream? It's called Errors and Exceptions. That's not the right title. What are we doing? We're doing functionally solving problems. Should we do this? Should we try to do algorithms? I guess it doesn't hurt, right? So let me update the title here. Functionally solving problems. All right, I've updated the title. That should work. And let's take a look. Sounds like we're ready to do something practical with all that Erlang juice we drank. Nothing new is going to be shown, but how to apply bits of what we've seen before. It's taken from Learn You a Haskell for Great Good. I decided to take the same solution so curious readers can compare solutions in Erlang and Haskell as they wish. You might find the results to be pretty similar. This is because once you know functional concepts, they're relatively easy to carry over to other functional languages. What am I doing? I was clicking on something. All right. I was just going to find OBS here. Here we go. Most people have learned to write arithmetic expressions with the operators in between the numbers, like this 2 plus 2, then divided by 5. This is how most calculators let you insert mathematical expressions, and probably the notation you were taught to count with in school. The downside is you need to know about operator precedence. Multiplication and division are more important than addition and subtraction. Another notation exists called prefix notation or Polish notation, where the operator comes before the operands. Under this notation, 2 plus 2 divided by 5 would become divided by plus 225. If we decide to say plus and divide always take two arguments, then divide plus 225 can simply be written as divide plus 225. You don't need the parentheses because the parentheses just tell you which are the arguments. However, we will instead focus on reverse Polish notation, RPN, which is the opposite of prefix. The operator follows the operands. In the same example, it's basically 2 plus 5 divide, right? So you see the plus, then you add the 2's together, then you do 5, and then you do plus. It's kind of like a stack. Other example expressions could be 9 times 5 plus 7, or blah, blah, blah. They just give you a whole bunch of examples. All right, this is the translation here. This notation was used a whole lot in early models of calculators as it would take little memory to use. Yeah, you don't really have to remember much other than the numbers that you've already calculated or need to calculate soon. As in, you don't have to remember the state of the multiply, divide, all that kind of stuff over plus and minus. In fact, some people still carry RPN calculators around. We'll write one of these. First of all, it might be good to understand how to read RPN expressions. What is this saying? Oh, it's just doing the work here, right? So here, it's kind of like I said, like a stack. You can imagine flipping this going up, right? So 10 is at the bottom and minus is on the top. So you kind of go from the bottom, you have numbers, then you have plus. All operators take two parameters, so you look at the last two, you add them up. So 4, 5, 6, 7. So it's 10, 7, 2, right? So next you would have 10, 7, 2 times, and times would take the 7 and 2 and multiply it, so you have 14. And then 10, 14 minus would give you negative 4. I don't know what this all is. However, in the context of a computer or calculator, the simple way to do it is make a stack. Yeah, that's what I just, whatever, guys. Okay. I hope that was clear, right? Hopefully it's clear. If it's not, please leave a comment. I don't know sometimes if I'm going too fast or too slow in these things. Uh, Writing this solution in Erlang is not too hard once we've done the complex stuff. It turns out the tough part is figuring out what steps need to be done in order. All right, so should we just try to write it? Oh my God, how many jobs do I have? What is all this? Is this important? No, this one isn't important. I think we were writing this in the last session. And I have my signal running. This was a work session. All right, so this is okay. We'll leave signal running. Um, so the file name is rpn.url, which means the module has to be RPN. It has to match the thing. What is the thing called? Like where you compile, where you tell it to export all? Is it like X? I don't remember. Where was it? Compile, export all. This is a directive to tell the compiler to just export all functions because we're lazy. Um, so what do we do? Are we assuming we're going to give it a string? I guess the top level is going to look a little bit like calculate. And are we going to give it a string? I guess we'll give it a string. 2 plus. And it returns the solution. Okay. When is binary S? Oh, I'm writing Elixir. How does this work? I forget. Oh yeah, it's like this. Um, and when you calculate S, we'll probably, what do we want to do? We want to grab, we want to look at the string and probably tokenize it. So maybe we turn like, yeah, we'll just return 0 for now. Okay, we got to implement this guy. And the other thing we have to do is, I was thinking we can either get the next token all the time, which is like next token out of the string, or we can tokenize the whole string and bring back a list of plus operators, minus, all that kind of stuff. Maybe we just get the next one. Oh look, just by cheating, they're using string tokens. Let's see what this does. We'll just return this for now. Let's see what we get back. Hello, Yilia. How are you? Um, Now we run Erl, we compile RPN, and no clause will ever match when S is binary. Why is that? Oh, because it's an atom. Variables in Erlang need to be capital letters. Okay, there we go. This is just a warning. We can ignore it. All good. Got burnt out of my project, so now I'm watching other being more productive than me. I am barely productive. This is me just like crawling. I just got out of bed. I made a coffee. I had a coffee. Mondays are the worst. Don't beat yourself up. It's like 1 p.m. and I'm just out of bed. I didn't shower. I feel terrible. I feel terrible being in front of a camera like this. But whatever, like sometimes you just gotta move forward a little bit. So I am now reading on my in my Erlang book, trying to finish this book, or at least most of it. And we're trying to write an Erlang reverse Polish notation calculator. So we've compiled that. So now we can do RPN, which is the module name followed by calculating. We give it a string that is a bit like what we think we'll do. So we'll first add those two numbers and then we'll divide and we'll see what it does. It doesn't like no function clause matching. Isn't that what binary is? Here, let's just do it this way. Undefined string tokens. Okay, so we have to import tokens. How did this work? Import tokens. God, I've forgotten everything I've done. Let's see here. Let's look at some of these other ones. Export. Do we have any imports? No, I shouldn't need to import string tokens. String tokens S. Tokens string separator list. Maybe we have to give it the second parameter. Space. Wow, I'm really doing a bang up job here today. Oh my god, what's going on? It looks like I have caps lock mode now on. All right, compile. All functions will be exported. Okay, this time it compiled. RPN calculate hello world. There we go. It's tokenized it. It broke it up um into two strings. No idea what Erlang is. Yeah, I have a YouTube playlist. It's um it's all about learning Erlang and we're like pretty far along. I don't know what chapter this is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're on chapter 10. Um, all right. So this will tokenize everything. So now we'll just have a list of, oh, I wanted to figure out like why can't I do when is binary here? Why let's try this again because this is basically a guard and it's saying that this function will only run when no clause will ever match. Oh, when is binary S. There we go. When is binary S worked. And now I can do calculate. Nope. So that hello world is not a binary. Let's go back and figure out what is the right guard for binary. Is binary, is boolean, is bit string. I don't think it's a bit string. It's definitely a list. So maybe I am confusing. Yeah, I guess I'm confusing Elixir and Erlang. This must be is list, which seems kind of weird because it's a string, but I don't see anything better. Let's see if this works. That compiled and that worked. Okay, perfect. So that's really weird. It's like you can't differentiate, at least from what I can tell, between um a, something like this and passing in a list. Right? That's kind of weird. But I guess if I put in a space in here, how do I do that? Like this? No, 32 is space. 32 is space ASCII for space. And now it'll break it up. You see? All right. Where were we? Now I've lost a thread. Okay. Let's go back. So now we have tokens. And now we can I think we can use reduce now. Fold, that is, to do the rest. Yeah. So where was Erlang fold? How do I should learn how to look for Erlang stuff. Let's see, how do you search for Erlang stuff? User's guide. No, I don't. Do I want this? Probably Google's the right answer. Standard lib. Lists. Where would fold be? Probably in here? Nope. Well, let's I think it's under lists. Here we go. Lists. Fold. There we go. So now we can do list fold L, and we pass in a function. This is our anonymous function, right? We're going to be passed in the element, so we can call it, I guess we can call it X. And then we have the accumulator. We need n to end the function. And here's our function. So, wait, doesn't fold take three things? Yeah, it takes three things. Function, accumulator, and list. Function. Wait, what? Why do I feel so confused? I think this is fine. I think this is all we need. And now, so we're going to get the element, so it's going to look like 2 or plus, right? So now we need to just check what it is. Um, I think we can use the if statement, or should we use case? Let's see, case x of, trying to remember the format for case, the syntax for case. I think we have that in here. Case member of blah, 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 end. All right, so I think I can handle that. Case of, and now we can have a number. Is number n. We'll just return the number. Let's do a version where we just like, does this need a period? I don't know what this needs. And then otherwise we just drop it. Oh, we have to return the accumulator, right? So the accumulator is the list of numbers we want to return. So let's just, for our first test, we'll remove all the operators. So we'll just do accumulator plus, we'll put n in the beginning of the accumulator. And otherwise, we'll just return the accumulator. This effectively drops the thing. All right, I'm sure I'm missing stuff here. Syntax error. All right, let's go back and look at case. All right, so there's a semicolon here. So we need a semicolon in our states. There we go. And here, I think we put a dot at the end saying this is the last statement. Syntax is a little hard for Erlang for me. All right, so now we have our fold, and if I did this right, the fold should basically remove all operators. So let's try that out. We'll compile, and now we'll calculate, and we'll pass in 2 plus, well, that's not really accurate. Divide, something like this. All right, it doesn't like fold L. List fold L. We have to pass it the, sorry, I'm doing such a terrible job. Function accumulator list. Function, that's this. Accumulator. The accumulator should be the empty list. And then the list we're operating on here. So this is our token list. I don't actually know what. There we go. How's that? Syntax error. Great. Great. Fold L. Oh, no, 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 no. Oh my God. Guys, you'll really forgive me, please. So here's our function, right? The function ends here. So this is us passing in the anonymous function. And then we pass in the accumulator, which is the empty list. And then we pass in the thing we want it to fold on. Yeah. Okay, somehow I don't think I'm matching the right number of. Yeah, okay, that matches. Why does this look so weird? This ends to fold. Return this. Syntax error. Why syntax error? This is the function. No, this ends the case. I need to end the function. That's why it looks weird. There we go. I knew something was weird. Still doesn't like it, but we're better now than before. End. This ends the function. Then we pass in the accumulator and then token list. It doesn't like token list. Why? Wait. That's how it's supposed to look. What's going on? Is it really that like I'm waking up and my cognitive function is just low? I don't think this would normally happen. Or it's like Erlang isn't loaded in my head. Okay, so what I kept doing wrong was just have to think about what's being passed in. This whole part should be the function here. After the open parentheses. So I guess like it would be more clear if we did it like this. So you can see this is the function. That's the first parameter. It's an anonymous function. This is the second parameter. This is the third parameter. And this closes our fold call. Like maybe indentation. Just be better with indentation. And I need this. So that's what went wrong. Hi there. Runston. Oh, thank you. You told me my error. Jesus Christ, I'm so sorry. That must have been frustrating as fuck for you. I'm sorry. Oh my god. I really don't know. I really don't know what's going on. Okay, so we compile everything, we run it, and it didn't do what I wanted it to do. Why didn't it do what I wanted it to do? I'm pretty sure that this is correct. IO format token list. And then what? P N token list. I'm pretty sure this is correct. Yeah, the token list is this. Oh, these are not numbers. That's why. These are strings. So, we have to like look for the type conversion stuff. So let's do it the other way because that's a lot easier. Where we check if it is a plus. I wonder how to do that. How do I need to convert type conversions. Here we go. We need So what's this going to look like? It's going to look like it's going to be the plus number, the number for plus. So how do I put that in here? I guess we can just look at the ASCII for plus, right? How do I do this? Um, is it list to integer? No, I don't think we can do plus here because this is a list. Oh wait, maybe this will work. You're right. Maybe this will work because this is a list, but we're going to get back as a list also. Yeah. You're right. So we'll return plus followed by the accumulator. We'll just know that, we kind of did something here. Um, let's see if this works. There we go. We have a plus. And if we add a few more pluses in here, we get plus, plus, plus. Perfect. Thank you. It's going to be my day, I think, where I just don't think at all, right? Oh, so the problem with fold is that I won't be able to see the previous numbers. So this is kind of like a problem, right? Because I want to access the last two numbers now. So it's almost like I want to pass the element plus all the previous elements also. I was thinking it would be the actual answer, but I don't we can't do it just as the answer, right? So maybe it needs to be, yeah, it needs to be everything that's not been calculated. You're right. So I should be able to look at accumulator and just assume that it's everything we haven't calculated up until that point. That's very smart. Okay, so let's assume accumulator has the calculation in progress with the full stack. With the stack that hasn't been evaluated yet. If that makes any sense. So if we get a plus, then we want to look at the accumulator and grab basically the last two items, right? So what does that look like? It looks like we have the head, which is the plus item, right? That's this. And in that, we have the second item, which is going to be the, whatever we call it, like value 1, followed by value 2, followed by tail, right? And this is equal to the accumulator. And now we can basically return value 1 plus value 2 followed by tail, because we've basically popped the plus sign, the v1, the v2, we add them together, and we return this. How's that look? Does that look reasonable? maybe? Except that the stack shouldn't be evaluated. The accumulator has numbers have been converted to integers so that we can actually add these numbers. So we have the plus, and then here, let's assume everything else is a number. We will call, what is it, list to string? List to integer. There we go. That's, I think, what we want. Yep. What's going on? Looks like I had some kind of like cap shift on. So we do list to integer n. That is right. So otherwise, this will be the fallback. It'll assume it's a number and it turns it into a number and puts it in the front and calls and adds it to the accumulator. I think this is good. Oops. Oh, it doesn't need a thing at the very last one. There we go. Okay, let's see if this works. So now this should give us like 5. Nope, it didn't work. Token list, no match. Right hand value 3, 2. 16. Oh, it's not matching here. Let's just try giving it without the plus. Yeah, so that is sort of right. It inverted it. But then why did the plus not work? Ah, because it should be x here. Oops. Okay. No, that didn't work either. 16. Why didn't this work? No, I'm wrong. This shouldn't match. I was right. It should look like this because we're trying to grab stuff out of the accumulator and we don't have the plus there. The plus is in X. So we're grabbing V1, V2 out of the accumulator because we know we have at least 2 numbers in the accumulator. And then we add them. Okay. Come on. And I keep doing it wrong. I'm literally making every mistake possible. There we go, 5. Jesus Christ. Jesus Christ. Isn't that incredibly bad? Wow. All right. Am I swapping order here? I see a number. I'm going left to right. So it looks like two. Hold on. So if I have 2, 3, 4, 5, it's going to return 5, 4, 3, 2. Yeah, that's not right. It should keep the same order. So I want accumulator plus list to integer. 2, 3, 4, 5. Um, okay, so we've done plus. We can do minus. And we just change this to minus, right? I think it's, yeah, V1, V2 minus. So let's try that out. So if we plus this, we get 5, and then we subtract by 1. Oops. And we have 4. That seems right. And then we subtract. Let's just do something like 16, 20 minus. Okay. I've convinced myself this works. Let's do multiplication. Notice we're pattern matching the same thing all the time. So now we have multiplication. And we just do this. We have division. We just do this. Right? So ways to improve this, we could definitely like map these symbols to a function and pass the function in instead. So we use higher order functions that way. But let's just check if this works with their, I assume they have test cases here. We can use this one. Should be -4. Wait a minute. Why doesn't list integer work on this? List to integer. I'm confused. What? Oh, that's not what I want. it doesn't make sense. All right, let's figure this out. So if I add this, I get 14. Oh, it added these two numbers. Why? It added two. Yeah. Oh, because I'm passing the accumulator. And I take the first two values of the accumulator when what I really need to do is pop. At least ASCII list provides for fun bugs. Yes, sure does. So I'm pulling from the far left of the list when I should be popping from the list. So let's write, there must be a pop function already for Erlang. La la la. Or maybe it's, actually, if I put stuff in the accumulator in reverse order, then I don't have to change the logic. So what I had before actually worked. I just didn't know it. You know what I mean? So like if I put it backwards here, then I think this should actually work. Yep, now it works. Because before we were taking, if it was in the same order as we were getting the input, then we're getting stuff out of the leftmost values of the list, which is the bottom of the stack, but that's not what we want. We want the top of the stack. So if I put it backwards, then it's the top of the stack. Uh, I don't think you can do that. What is, do you mean like you're constructing a list here, right? So you're saying something like having a head like 1 and then passing 2 comma 3 here? I don't think that actually works. And but it would work if this was a list. Oh no, that I don't think that will work. Oh shit, dude! What? So what that means is I should be able to decompose this like this, right? Let's check this out. Let's check this out. Fuck yeah. Oh my god. I'm not sure I like this notation, but it's pretty cool. Get rid of that space comma here. Okay. Well, cool. Thank you. Go with the magic all the way. All right. Where are we? So, what do we not like about this? Don't really like that we have this part duplicated all the time. I also don't like that we need to do plus and plus here. So it'd be kind of neat to have something like, um, let's figure out how to call the plus operation. I bet it's like Erlang add. Oh, Erlang. No, not Adler. Add, no. It's not standard library. No. Where would we find like the basic stuff? Let's see. Erlang add function. Yeah, none, Mojik never knows this stuff. Nope. Do I have something here? How do I refer to the plus function in Erlang if I want to pass it to another function? Uh-oh. How do I do a new chat? Oh, it's just Erlang colon plus. So what I was thinking of doing was, it might be nice to do, yeah, here's apply, and then we pass in Erlang plus. So something like a map. Did we learn? We didn't learn maps yet, have we? No, so I can't do it. I don't even know how to do maps. I could make it a list of tuples. We could do that where we have the symbol, so it's like plus, and then the function Erlang plus 2. Let's see if we can make this work. Okay, so I've made a mapping here. And then I get passed in a term, which is going to be plus minus times equals. And I just do there must be like a find here, lists, all, filter, join, key find. Where's the one I want? Probably key find or key find map, key search for each, flatten. Searches the tuple. What? Key and tuple list. Tuple. I'm not sure if that's even what I want. Key and tuple list. Like, list of tuples. Tuple is a tuple. Key is a term. N tuple size. Oh, so it's looking in the tuple. What? List key map fun 2. I feel like I don't know what's going on here. Maybe we do it ourselves. So we have the mapping here, and now we want to call maybe the functional gods would be more pleased with something that looks less suspiciously like data. What data? You mean this? This part or this part? Yeah, this mapping looks like data, but what am I supposed to do? It needs to know like what the how to map the operation to the function, right? I mean, I could pass it in somewhere else. I would probably have a const here, but I don't even remember, like, I don't think we've learned how to do consts. Or, like module-based stuff. Module declaration. Maybe we did learn it. Let's see. Defines a macro as an atom. This is more frequently used when dealing with unit testing, ensuring a module. I think we can probably use that, but I'm not sure. Oh, don't worry. Don't worry. I won't be upset. Anyway, I feel like I'm just really going slow here. So function takes in the term and an accumulator of some sort. It will return. We'll also pass in the accumulator starts off as I guess it starts off as undefined. And the list we pass in is mapping. Okay, and then if we have a matching element, we basically look at the term that we're looking at and we say, is it matching the operator? X function is equal to, can you help me think straight, please? So we got the term in here. The term is just going to be plus or minus, right? Plus or minus. So we want to know whether it matches, X matches the term. So we want to do term here and we want to do term here. There we go. So if the term matches, this might throw an exception saying that doesn't match. No, this is not what's going on. First, we have to look at X. We break X out, right? X is the item in the map, right? So X has this shape. There we go. We'll call it X term. Not that that's complicated, right? And then we do if X term is basically equal to if the X term is equal to the term that we're passing in, then we found the match. Then we return, I don't know how, I forget how this works, right? But it's like, then we return the function. So we return the operation function. There we go. Otherwise, we return undefined. We got to make sure we don't overwrite undefined. So we return basically, if it's undefined, then return undefined. Otherwise, return the accumulator. All right, let's see how the format for if statements work. If, end. If, dot, 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 end. Okay. If, then this. Otherwise, this. And then we need an end for the if. And then we end the function. Okay, great. And then we fold this. This will return the accumulator. And that should be good. All right, why are we unhappy here now? Because we're not happy. We're definitely not happy. Somehow it doesn't like my function at all. Let's see here. Mapping, this we know is good, right? Like we know this part is good. No, well, we don't use mapping. So if we return mapping, then it's happy. Syntax error before mapping. Okay, this is good. So we just get rid of this now. And now I bet I have a problem here. We don't need this. So let's make sure this function looks good. Remember what I said before. Let's match stuff. Here's the function. This is all part of the function. This is part of the if. This should kind of be somewhere else. I don't know where to put it, like here. Kind of a weird thing. And then this ends the function. This ends the if. This ends the function. This is the second parameter to fold. And this is the third parameter. So maybe we call fold wrong here. Let's see. Oh, it's list fold. There we go. Closer, but Xterm is not happy because I typed it wrong. Now we're happy. There we go. God, I am so stupid today. So this should return the function that matches here. Why is this not happy? Illegal expression. Maybe it's wrong. Let's see. Maybe we do have to write function here. Yeah. Okay. Now let's try compiling it. And now we have something called get function, I think. And we pass it in just a term like plus. And it gives me this. And I think in terms of running it, I can do apply function, pass in the function, comma 2, comma 3. No. Maybe it's just apply. Oh my god. Okay. So that's not how apply works. Looks like it needs a list. There we go. Apply function, pass in the function, and then the list of parameters. Um, you can practice. I'm totally blaming Erlang. By the way, I was thinking of something like case term of plus Erlang plus. You mean like up? Oh, instead of this mapping thing, you just make this a case. Oh, I love that. For some reason in my mind, I just got stuck that I wanted a configuration of all the operators, and I didn't change my mind. You're absolutely right that that actually seems like a better way, but I just figured like somewhere later down the road I would have this config file that has like a list of fucking symbols and symbol names. It makes no sense. Anyway, we're down this road. But yeah, effectively yours would basically make it not have to use a fold in here, which is so much better. But I'm glad I did this because I fucking needed the practice. That's the word. Maybe I shouldn't work today. I feel like everything's going to be bad. I don't think I'm always like this, am I? This is so humbling. Anyway, where were we? We get back to function now. I guess we've implemented this. Let's leave this for now. And now let's use this here. Which means we should be able to do something like get function x, right? And then we can do something like we can still grab this. This gets a little tricky. We want to oh shit, what am I doing in fold here? Right. No, I think I still need to do if it returns instead of undefined, I could just return it as a number, right? Maybe that's a good thing to do. So we just return term. Is this gonna fuck me up? Yeah, I think this is gonna start my fold with the term in the accumulator. And then it'll go through everything. And it won't change the accumulator unless it finds the operation. I think this works. Um, let's I think this code should still compile, right? And then plus returns plus, divide returns divide. But if I pass in 2, I get back 2. So now what I can do is it's really get function or operand, right? list to integer term because I'm turning it into a number. And then instead of get function, this is really like this is really tokenized, isn't it? Let's just call it get function or value. So here we call get function or value. And now here we have function or value of x. So now we're checking case of function or value. Value when is integer value, right? So when we have it as a value, it's a number. We just put the value in here with the accumulator. Wait, what was the stuff we put in between? Semicolons? And then otherwise, we know it's a function. Is there an is function? It was under conversions. Where's the guards? They don't give you a list of guards? Whatever. I think it's like is function. Then we just apply. We pass in the function followed by the arguments, right? Which is we need to pop this. So we do what we had before, value 1, value 2, rest. We apply it, and then we return tail. Does this look good to you guys? Does not like this. It needs to match. Is equal to accumulator. There we go. Our accumulator has all of our values so far. We break it out. Then we apply the function and get tail. All right, let's see if this works. We haven't done it in a while. Come on. Oh, well, we don't have it. Okay. Let's find out the example they gave us. Here it is. Is this it? RPN. Calculate. Okay, we have a problem here. Called as list to integer number 2533. Ah, Right, it's going to that doesn't work. Wait, hold on, think. So our term right now is plus. We want to find the mapping. So we go through and we're like, hey, what do we return? Um, yeah, this is not right. We'll have undefined here, and then we'll have the return value here. Um, and then basically, if return value is equal to, we'll just do if it, yeah, we'll just do is equal to undefined. Then let's return list to integer the term because it means we didn't find a function, so we're going to return the integer version of it. Otherwise, we return the return value. This is really the function. Found function. Does that look right? This makes this a lot more work than the version that you suggested. Oh, come on! No right hand side 14. What? Oh, 44. How can that be? It was a function. I must have at least two values in the accumulator, right? So where did it have a problem with this? Oh, I just copied it wrong. There we go. I don't know why it's not -4. Aha. I somehow reflipped it. Probably here. Ice cold witch. What's my favorite programming language? Right now it's Elixir. In imperative programming languages, I also tend to prefer to amass the logic into data and the code being devoid of business logic. In functional language, code is data, and functional language code is data and code is elegant, so no need, I guess. It's Python. This is not Python. This is Erlang. It's in the title of the stream. Oh God, I feel so dumb today. You ever have those days where nothing seems to make sense in your head? Okay, so in here, I'm not switching any variables. And in here, I'm picking the first one. Oh, it's here. It's because I'm reversing. This should be variable 2 and variable 1, I'm sure. Minus. Yeah, it has to be this. What? Yeah. All right. So now when we do this, this will give us -4. And we're happy. It's sort of like fourth is reverse Polish notation, right? And that's what this exercise is, and I just did it really stupid. All right, let's now do the last thing and fix it so that I feel like this is okay. But let's go over here and do what Rorston said. So if term is plus, then we return this. If it is, let's see, I think I can just do like this and just delete that, delete this, do that, delete that, and let's change this. List to integer n, right? Does that look better? So I think this should work. Get function or value. Let's test it. RPN get function or value. We pass it in a plus. We get back the plus operator. If we pass in a number, like 12 in ASCII, we get back the number. And now we can call calculate. Let's see if we still have the, here it is. -4. This should be a dot, right? Okay. Okay, that looks like a fucking ton better. We can even like calculate one. That way we don't have like, why did it lose my data? What's going on here? Yep, it's a calculator. That took a lot more work than I would have liked. Whoa, they have a whole bunch of stuff here. Four oh three seven, yay. All right, I could add these, but I'm pretty sure they'll work. Let's see, what did they do? They have string tokens. If it is a list, then result we fold function RPN2. So there's going to be an RPN2 function. That's like a helper function. Start with a list and tokenize it. The accumulator starts off as a list. Where's RPN2? Here's the RPN2. So it passes in a stack, it reads X, and then it returns the stack. This is kind of like our get function or something. String to float. See, this is a useful thing to know, huh? String to float. What is this? Oh, I see. So if this is an error, then it does list to integer. That's so smart because basically if our thing ends up with non-integers, we're kind of screwed. So they've handled it by adding a case statement that falls back to list to integer. That's so smart. Um, yeah, this is kind of like something similar to what we have, and they did do the exact same thing that you said with the comma. And then you just have to add all of these states, which is similar to our get function. So they didn't do the thing we did where they actually passed the function around, which I thought was pretty cool. But this works. All right, I think we did it. So here's the end result. Get function or value. I think this is pretty clean. You have one place to basically add all the terms instead of like repeating the function over and over. And then we fold through our situation. We get the function or the value, and then if it's a value, we add it, we keep it in the stack, and if it's a function, we get the last two elements in the list, in the accumulator, the stack basically, and we apply it. We start the accumulator with an empty list, and we pass in token list, which is the list of tokens we broke up from the original calculate. All right, I think that's it. Now make it Turing complete. Sure. Not too hard. We'll just call eval. I mean, once you have apply, you can kind of like write code in here, right? All right. We've been at it for an hour and 40 minutes for this small thing. I can't believe it. I apologize. I feel so bad. Um, Heathrow to London. Let's take a look at what the next one's going to be, but I don't think I'm going to do it right now, especially not in my state. Next problem, blah, blah, blah. You're on a plane due to land at Heathrow Airport in the next hours. You have to get to London as fast as possible. Your rich uncle is dying and you want to be the first to claim dibs on his estate. There are two roads going from Heathrow to London. So you're at the airport and you want to go to the deathbed with the gold. And a bunch of smaller streets linking them together. These are the smaller streets, and here's the big street. Some parts of the roads and smaller streets take longer to drive on than others. Before you land, you decide to maximize your chances by finding the optimal path to his house. Here's the map. So I guess these are the weights. So this segment is 10. This is really bad. Like whatever street this is, it looks like you would go like 10, 40, 45. Yeah, 45, 65, 67, and then you would get like 75, right? Like it seems like that would be the way to go. The choice is only between picking which of the path A or B is the shortest. Wait, hold on. The first thing to do is find our base case. For our problem at hand, it would be if we had only one tuple to analyze. That is, if we only had to choose between A and B and crossing X. So we have triples here. Anyway, we can tackle this problem later. It looks like the A star algorithm, but maybe it's a simplified version. And we will do this next time. I thank you for hanging out with me. Like and subscribe if you see this on YouTube. Um, I got a shit ton left to do today, and I have a feeling I'm going to be struggling if this exercise is any indication of my current mental state. Thank you. I'll see you guys later. Bye. I'll probably be streaming tomorrow.